Today we're going to look at section 4.7b, vertex form of a quadratic. Our objective is to be able to use completing the square to put a quadratic equation into vertex form. So let's remind ourselves of what vertex form is. It's y equals a quantity a times x minus h, quantity squared, plus k. I am going to go through our 5 examples today a little bit quicker, just because we have done completing the square already, so it shouldn't be too hard to kind of go through this, and then hopefully we'll be okay with everything. Okay, so the first one, y equals 2x squared plus 16x minus 4. So again, since we want that quantity squared, we can use completing the square. So it's going to be done in usually like 3 easy steps. So I have y equals, remember to complete the square we can't have a number in front of x. But instead of moving things to the other side, since I have a y, I'm going to keep everything on one side. So I'm just going to factor out a 2, but only from my x terms. And the reason I'm only doing it of the x terms is because usually for completing the square we would have moved this 4 over to the other side. But all I'm going to do is move it over here to the outside. And it's going to stay negative 4 because I haven't changed the sides. And I'm going to put a blank because I can't do something to a side without negating it somehow. Okay, so this looks kind of similar to what we did before. Typically we would divide by 2 and move this to the other side, but I like to keep it all on one side for vertex form. So again, how do we complete the square? Well, we're looking for a number that would go here, that when I factor this I'd get a quantity squared. And if you remember from completing the square, we take half of our b terms, so half of positive 8 is positive 4. But if you remember, 4 squared is 16. Now the only thing here is I can't add 16 to a side without getting rid of it. And actually, because this is inside parentheses, this really isn't a 16 anymore. It's 2 times 16, which is a positive 32. So if I add 32 to a side, the only way I can negate that is to subtract 32 from the same side. So these cancel out, would reduce to 0, so I didn't really do anything to change the problem. This now becomes negative 36, and I just put this into vertex form. I could find the vertex, which is negative 4 and negative 36, and I could graph it if I'd like. Let's see that again with a different example. This time, instead of writing y equals, I have f of x equals, but if you remember that means the same thing. This is just called function notation. So I'm going to keep it as f of x. Again, I don't want to factor, or I don't want to complete the square with a factor in front of x squared other than a 1. So I'm going to factor out my lead coefficient of 3 only from my x terms. So when I factor out a 3 from my negative 30, I get negative 10x plus blank. And then I'm going to move this 1 all the way to the outside. And again, putting a blank. For my last step, I'm going to have my 3. X, half of negative 10 is negative 5, quantity squared. But remember, I have to complete the square because this didn't exist unless there was a 25 here. But again, this isn't really a 25, it's really a positive 75. So if I add 75 to a problem, I have to subtract 75. 1 minus 75 is a negative 74. And this is my standard form. This would have a vertex of positive 5, negative 74. Let's try that again. This one looks a little bit simpler because I don't have a lead coefficient. If there's no lead coefficient, I don't have to worry about factoring out, but I still want my parentheses to separate my x values, my x terms, from my constant, just my numbers. Alright, so this one is one of our odd numbers. So again, half of negative 7 is negative 7 halves, quantity squared. But I want to square this to put it on the line. So 7 squared is 49, 2 squared is 4. Now remember, there's an imaginary 1 here. 1 times anything is itself, so if I added 49 fourths, I have to subtract 49 fourths. Now I just have to do a little bit of algebra. Remember, 3 over 1 is equal to 12 over 4. So if I have 12 over 4 minus 49 over 4, that's 12 minus 49, which should give me a negative 37 over 4. So this would have a vertex of positive 7 halves, comma, negative 37 over 4. Okay, let's try 2 more. This one has a 1/2 in the front. That's okay, we're just going to factor out a half. This tends to be a little bit harder for some students because they don't know how to divide divide by a fraction. But remember, dividing out a fraction is the same thing as multiplying by the reciprocal, and the reciprocal of 1/2 is 2. So I would multiply this by 2. You can always do the algebra distribute to make sure you did it correctly. So let me show you how that looks. 1/2 times x squared is 1/2 x squared. 1/2 times negative 2 is negative 1x. So that's my check to make sure I did it right. My last step, I'm going to put my 1/2. X, half of negative 2 is negative 1. Quantity squared, but again, this didn't exist unless I square that number and I get 1, because this factors down to x minus 1 quantity squared. But again, I didn't really add 1 to this side. I added 1/2. So I'm going to subtract 1/2. 10 minus 1/2 is 9.5, but again, we don't like mixed numbers. So what that is really is 19/2. Again, this would have a center at 1, a vertex at 1, 19/2. And let's look at one more example. This went back to my function notation. And the reason this is trickier is because I have a negative 4 in the front. That's not going to change my first step. I'm still going to factor out a negative 4, but now I have to divide 18 by negative 4, which is negative 18 divided by 4 reduces to 9/2. X plus blank. And then move the negative 8 over. And then for my final step, I keep my negative 4. But now I have to take half of 9/2. When you take something and divide it by 2, it's like multiplying by 1/2. If I multiply this fraction by 1/2, I get 9/4 instead of 9/2. That's what happens when you cut 9/2 in half, you get 9/4. Again, we're going to square this, which is 81/16. But I didn't really add 81/16. What I did is I subtracted 81/16 times a negative 4, which gives me a negative 81/4. 4 reduced with 16 4 times, so I get negative 81/4. So to get rid of 81/4, I'm going to add 81/4. I need a common denominator. Negative 8/1 is equivalent to negative 32/4. So I have a negative 32/4 plus 81/4, which is going to give me a positive, let's do this, 949/4. And that is it in vertex form. Again, this would have a vertex of positive 9/4, comma, 49/4. Sometimes the numbers work out really nice. Sometimes they're big, sometimes they're small, some positive, negative, and fractions. But this process of what we did for completing the square is the same. I hope you feel a little bit better about putting a quadratic into vertex form by using completing the square.